Welcome students. Since you have told me that in Zoom app you didn't understand the short transmission line explanation, I am redoing that. Let me start with this. You know already the resistance and reactance. You know there are three different transmission lines: short, medium and long transmission line. First I am taking up short transmission line. Short transmission line is based on the distance as well as on the operating voltage. It can be classified into three. That first one is short, next one is medium, next one is long transmission line. So coming to short transmission line, here you know that in every transmission line there will be effect of resistance, inductance and capacitance. But here in case of short transmission line, there is an effect of only resistance and reactance, that is inductance. We will see how exactly it is there in the present in this short transmission line. The resistance, this is the equivalent resistance of the transmission line. This is the equivalent reactance of the transmission line, I mean inductance. Now, the sending end voltage is here and the receiving end voltage, that is load, is here. So, the power has to be transmitted from this point to this point. So, while transmitting the power from sending end to the receiving end, what happens and what is the what happens to the efficiency and what is regulation and what are the losses? We have to look into it. So let us start one by one. Before I get into the derivation, first let us start writing the phase diagram. That phase diagram looks like, you know that. Let us start from the receiving end voltage. This one, receiving end voltage. VR means VR stands for receiving end, IR stands for receiving end current, and IS is sending end current, VS is sending end voltage. I will start from this VR. We know that. What is VS? VS is equal to VR, this voltage VR plus VZ. VZ is this voltage plus this voltage is exactly the voltage, this VS. So if I want to find VS, then I should find VR and VZ. Let us identify first VR, next let us identify VZ, next combination of this vectorial addition of these two quantities will give us VS. I have to identify VR. Before I write phasor diagram, first with respect to what you are writing the phasor diagram, first you have to take the current as a reference. So which current shall I take as a reference? You know that it is a series circuit. Whenever there is series circuit, always we have the practice of taking current as a reference. So let us take the current as a reference. So which current? The current flowing through the circuit. How many currents are flowing here? There are two currents. One is IS, other one is IR. But since it is series circuit, IS is equal to IR. That's why if I take current as a reference, so let us write the current, a reference line here. That is the current through the line I am taking as a reference, where this I itself is equal to IS, which is equal to IR, which is equal to the total current which is flowing through the line. That is present in this line. Now let us start from this current I have taken as a reference. With respect to this current, I should write where I should represent VR as well as I should represent VZ. So now let us start from the VR. First let us see where VR comes. Now, we are assuming that inductive load. In case of inductive load or in case of inductance, VR, the voltage leads and current lags. That's why by how much it leads and by how much it lags. That is, with respect to this current, this voltage leads by some angle. That I am writing here. I am calling this as VR. The angle between IR and VR is phi R. Once I got this is over, I identified VR. Let us come to VZ. When I come to VZ, you know that you have two elements. One is resistance, other one is inductance. So summation of two drops is equal to VZ. So what are those? There will be voltage drop across the resistance, as well as there will be voltage drop across inductance, VR and VL. These two, sum of these two will give VZ. So if I want to find VZ, then this, let me not write VR, I will small r, VR, VR plus VL, because already I have used capital R for receiving end. That's why you may get confused. So now instead of capital R, I am using small r here. the voltage across resistance, this is voltage across inductance. So when I add these two vectorially, I will get Vz. After getting Vz, let me substitute here. That summation of these two will give me Vs. So I have to identify Vz. If I want to identify Vz, I should find Vr and then I should find Vl. So let us find one by one. Now you forget other part of the circuit and only concentrate on resistance. You can see the voltage across this resistance is Vr. What is the current flowing through this resistance? Is. So what are these two relations? Since it is resistance, it will be in phase. Wherever Vr is there only Is will come. They don't have any phase difference. Now where Is is on this line. Okay. So if I know Is, the current flowing through this as well as this, only then I can find this. That's why where current comes here. So let me write parallel line to this. Parallel line. This parallel line is nothing but current. Okay, I am writing current. Either both Is or IR. Okay. I am writing parallel to this current because I want to add this VR component to this VR component. This product should be added, this component should be added, this magnitude should be added. That's why I am shifting this by writing parallel line. So when I write parallel line, I am getting I here, current. Now, do you know current through the resistance? Yes, I know. Then where voltage across this comes? On the same line. That's why on the same line, IR comes into picture. That is I into R, where I into R nothing but VR. You can write I into R. Okay. IR should be added with VL, where VL, this VR is nothing but I into R. IR drop is nothing but VR. Okay, this should be added with VL. So how to get VL? VL is nothing but, you just concentrate on this. This is an inductance. Voltage across the inductance is VL. So what is the current flowing through VL? That is Is. Where it is present? This on this line. With respect to this, where voltage across the inductance, it always leads by 90. This is VL. So now construct parallelogram to get the resultant. So when I construct parallelogram, I am getting Vz. The resultant will give me Vz. Vz. Now, did you get Vz? Yes. Vr is there? Yes. Already we have identified. So Vr plus Vz will give me Vs. So now I have to concentrate only on this which I am writing, which I am representing in solid line. The resultant will give me Vz.